Hello, welcome to this TouchDesigner tutorial. Today we're going to be looking at the line material, and as its name suggests, this is a great tool for basically stylizing different aspects of lines. It's a relatively recent addition within the last year or so I think there's a lot of things about it that are still worth kind of diving into and discovering. So I'm going to be focusing specifically on a feature that is kind of hidden. So, we can see from the material that we can vary the width based on the distance from the camera, things like the color. We can create joint and cap types, draw points, draw vector lines. All of these things are clear and you can start exploring them within the parameters. However, there's one technique which is varying the width across the line that is not really clear within this material, but I think it's a really useful technique. It's one that is actually, you can find it if you go to the operator snippets for line. There's actually an example that shows how to vary width, but it's not something that I would have really known how to do had I not come across that example. So I want to talk, just show one example of how to do this. This is basically varying the width and also adding some displacement and color based on the rotating of a rectangle to mask those changes. So we're going to look at making this network from scratch. So I'm going to go ahead and open up a new document and we'll get started. Great, so here we are, blank slate. And let's start by creating ourselves a grid, SOP. And this we're going to change a couple things. We're going to change the primitive to polygon and the connectivity to rows. So this will give us basically rows that will be used to create our lines. We also want to plug this into a null and then into a geometry comp. So we're going to do our sort of classic, like set up the render kind of pipeline. So let's do that. We'll add a camera and a render top. We're also going to want a null that I will set to display. And I'll go ahead and do this now. I'll split my screen, drag it over a little bit. We'll use the right side as a top viewer and the left side for the network. I'm disabling the backdrop tops. I'll also go ahead and change a couple things here. So 1080 by 1080 for the resolution on the render. And also, let's give it a background color just so that it's not our sort of transparency. So we'll want to change the fixed layer to 1. So there we go. Now we've got the 1080 by 1080. Now, we don't have any material yet, so let's actually go ahead and grab our line material, the star of the show, drop that onto Geo1 and choose the parameter material. So now we've got ourselves our line material. You'll notice it got a little thicker, and actually if we vary the, translate the camera towards the lines, they actually get a little lighter. That's because it's set to get lighter as we get closer to the camera, so that's sort of the default setting of this. For the camera, I'm going to go ahead and set this to view orthographic and ortho width 1. You can play with this, it doesn't have to be orthographic, but for our sake we're only really pushing it in the Y axis, so this just lets us keep the frame nicely lined up. And yeah, so here we go. We've got our pieces so far. So the next step is let's give ourselves a little bit of control over the sort of rows and columns, since we want to be able to adjust the system flexibly. So there's a lot of ways to do this in terms of where to store this information, but for now I'm just going to go ahead and create a constant chop, call it pairs for parameters. And we'll create 2 channels, one for rows, one for columns, which I'll call calls. Great. And let's set, for now, 50 rows and 350 columns, since we want a decent degree of density along each line. Now, I'm going to use some Python expressions to grab these values. So I'll type OP, parenthesis, comma, the name of the operator, pairs, followed by closing those brackets and comma, then another comma, the name of the channel, rows, and then I'll close the comma and bracket. So that's just a way that we can grab the value of that channel. I'll do the same for columns, pasting it and changing rows to calls. I missed a quote mark, there we go. Okay, so now we've got 50 rows, 50 columns. So let's see, there's like more of a density there. Actually, I should make this black. This is gonna be more along the lines of what we have. So black background, we can really see those lines show up. Okay, so good. We've got something to vary our settings later. So the next step is we want to start kind of manipulating this shape. And we don't want to do this in SOPs for a lot of reasons. One big one being that SOPs are very intensive on the CPU, but also there's not a lot of tools for it. So we're going to go to create a null. I didn't mean to branch it there, so I'm going to make sure, yep. And from here, go from SOP to chop. So we're really going to do a lot of our kind of data in chops and tops for this process. And then plug this into a null, and I'm going to now create a chop to SOP and drag my null back on. So far, nothing has happened. But what this does is it lets us take a given geometry that has a given connectivity. So we've got these rows, they're kind of defined that each one is connected in a row. And we grab the points, right? So we're grabbing the position, which is a attribute of the point, and then kind of plugging it back in when we convert it. So by plugging in this null here, we're just keeping the rows all connected in the same way, but giving them new positions. Now, the positions haven't changed at all, but you'll see in a moment how I can manipulate those points and keep them within their rows nicely lined up. So that's really the power of this method, and so you can plug in different geometry, manipulate it in chop space, and then send it back to SOPs. So cool. Let's start by just giving it some of that displacement based on noise, and now I'm going to grab a top. So you'll probably see later why we're doing this, because we could create noise chops certainly, but this is going to give us quite a bit of flexibility. So I want this noise to be the same size as my grid, so that each row of pixels represents a row of points. And so to do this, I can grab that same expression here. So the number of rows will translate to the height, and columns translates to the width. So just plugging those back in here. And now we've got 350 by 50 for our noise. Now let's bring this straight into a null and then convert that into a chop. So we're going to use this with our Y data in a moment. Now we don't need all of these channels. We really just care about one for the displacement. So I'm going to actually call this displace, so it has some kind of meaningful name. Under crop, I actually want the full image. So we should now have 50 channels, right? And I also need to shuffle this because I want this to be one long sample, right? So that it should be 17,500 instead of 50 of these channels. So I'll go ahead in method and choose sequence all channels. Now you'll notice it's the same length, so it's perfect for kind of like multiplying or adding or whatever you want to do to your other data. To kind of push this into our points, let's actually split this out. So I'm going to use two selects actually. The first one, let's grab on the bottom here just our TY, our Y position that will combine with our noise, and then just grab the other two up here. So I'm going to do T bracket XZ bracket. This is a nice way of using pattern matching to name channels. It seems kind of pointless with just two, but it can get really powerful. Let's plug this into now a merge just so that we can get it all back together. And still nothing's happened, but just give it one moment. So for our TY, let's add a math chop, plug these together, and combine chops. We want to add them. And there you go, something interesting happening. So if you look back at our noise and you say change something like the period, you can see that we're directly influencing the position of the points in the lines, but they're remaining connected in the same way that they were previously. So that's really key to getting this effect. We also, a couple things to change here. So you'll notice it's kind of like, there's some like blockiness to it. And also it has these like flat sections, right? So that's because our format is 8-bit fixed, meaning we don't have any negative numbers and we only have 8-bit resolution. So let's go to common and change this to 16-bit float, and you'll see immediately it's smoother. We don't have those flat sections. So a lot of nice changes there. Another thing we should do is let's drag the offset to 0, just because we want to displace in the positive and negative directions, away from the center. So great. So that's a good first step. Now let's also give this a little bit of motion, because I always like noise to be moving, almost always. So I'm going to type abs time.seconds, multiply that by 0.1, gives us some translation to Z. Also control, let's copy that expression, give us some also translation in the y-axis, so that's kind of like an interesting vertical motion too. Now, it's also pretty extreme right now. So I want a way to dial this in. I'm going to give us more space here. Here we go. So I could do this on the noise, but I'd like to be able to see what my noise looks like a little bit. So I'm going to do it over here instead, is create a math chop right after our displacement and just drag that multiply down a little bit so that it's not quite so extreme. Here we go. Whatever you want, but just a little bit smaller. Great. So okay, you can kind of see now how by feeding in different Y positions, we suddenly get varied line shape, forms. So that's like already starting to become really cool and definitely a powerful technique. But let's start to do some more things. So as I said, one of the kind of like hidden qualities to this line material is it will take a width attribute. So we're already doing this right here, where if we go to our chop to SOP, you'll see that it takes a channel scope, TX, TY, TZ, those are our channels coming in, and converts them to point positions, X, Y, Z. So we're going basically just swapping in the position for each point. However, there's a lot more attributes here, things like normals, which are used for like lighting or color, which we'll look at a little bit later. And so one thing that's not listed here, which this is why it's hard to know that it exists, is the width attribute, which the line material will take. You might think, oh, maybe it's point weight. That's what I tried first. It didn't work. So you kind of have to dig to find that. But I'll show you right now how that works. So let's, for now, just take that same displace so that when it's getting displaced, it's a little bit thicker, just to have those two linked. They don't have to be, but we're going to do that for this example. I'll branch off with the middle mouse button with a rename chop. We're going to call this width. And I also want to plug this into a math. We will start off by just doing something like negative 0.5 to 0.5, and then scaling that from like 0 to 10. Now we maybe 2 to 10, so it's not dipping into the negatives. Cool. Yeah, so that's a good start. And then I'll plug this into my merge. So I have my width channel here. And going back to my SOP, I'm going to grab width for my channel scope. It says, you've got more channels than you've specified. So now, instead of dropping down, we're just going to type width. And there you go. So it's pretty extreme right now. Let's dial that in a little bit. Let's go to our line material setup and change the width here to 1. Cool, okay, I like it. We're getting thin sections and thick sections, so that's already more interesting. And you can play with both this value here and also, dial it in at the math side too. So there's a lot of, both of those are gonna affect the width. Let's leave it for now, but that's basically how we can start to kind of vary the width across a line, and it doesn't necessarily have to be like a grid. It could be one line. It could be, really you can manipulate these XYZ positions as however you want, as long as they line up right in the same way. So it can be used in a lot of different, very flexibly if you think about the system. So cool. Okay, that's getting there. Now, one thing we had that I'd like to add is that mask, so that only where the shape is rotating, we're getting this displacement effect. So to do that, I'm going to also do this in tops, just because tops have so many great ways of creating shapes and patterns. It's nice to start there. So let's just for now use a circle. And oddly enough, I'm going to make it a rectangle, so kind of ironic, but here we go. Circle, my square that I'm going to use for the mask, and let's make this 400 by 400 just so that it's a little bit larger than our size. Now we want to basically take this and keep it in the same kind of like aspect, right? Because our output's also a square, but we then want to basically convert it into this shape, the 350 by 50. So to do that, I'm going to use a fit, and we're going to grab that same expression here for our resolution. And rows. Oops, I keep missing that comma. Great. And we don't want it to be fit in this way. Let's use fill. So it's basically stretching to that size. And I guess the next thing, we just multiply this by our noise. And you'll see how now we've got ourselves a rectangle. Now, a couple things here. Again, our 8-bit format is getting kind of like overriding here because the fixed layer is 2. So we'll change the fixed layer to 1. And there we go. We have our negative values, and our rectangle is now masking that noise. Now, let's do a couple things here. So a handy thing on the circle is this softness, which we can use to blur the edges, and that kind of simultaneously gives us kind of like a increasing noise value at the edges of it's like a soft kind of increase of that noise. So that's kind of a nice effect I like. Let's also make our square, a little bit bigger, and give it some motion. So I'm going to just transform this here with rotate. Abs time dot seconds times 10, because they're degrees, so we do want it to be rotating decently fast. And now you've got something more interesting. You've got that profile moving through the form. Now, one other thing that I did, I think I want it a little bit thinner actually. Let's just do that. Oh, interesting. Cool. Is color. So that's kind of our next step, right? And so what I did previously is I wanted the color to be rotating with the rectangle. That's partly why I actually don't just rotate it here. So I'm going to go ahead and create a ramp and just give ourselves some kind of color gradient. I think ours was blue to red. Multiply it. And so now we've got, maybe I'll pull this in a little bit because our square, there we go. So before we plug this in, you'll notice that now my color is being multiplied, which we don't really want. We really want this to just be based on the alpha. So a quick way to do this is use the reorder top and just choose alpha for all of these, which basically sets our transparency to the red, green, and blue as well. So that's pretty much exactly what we had before, and we don't have to make a second transform that's like linked to this one. You don't necessarily want that. So it's just a little bit of a hassle. So great. So now we've got our color, which we can branch off to a null. And in this case, let's just copy our top to chop, drop the null onto it. And okay, a couple things to change here. We need our red, green, and blue channels, right? We want all 3 color channels. And we also, in our shuffle, let's sequence these by name. So now we've got 3 channels, each of which is 17,500, so matching our length. And that's pretty much all we need to do for the color. We can plug it right in and change a couple things here. So again, we had to specify our channel scope. So it doesn't automatically know to do this. So RGB are our new channels, and we can just click point color red, point color green, point color blue, and we've got ourselves our color. So it's kind of nice like this actually, but we also, my example, I wanted those white lines to stay present. So let's just do that here in tops. Going to create an over and a constant. And funny, doesn't quite work right away, so we actually need to make sure that we're using our fit1 as the input that's fixed. So now we've got it, right? So this is pretty close to what I had. It's a little dull, and that is because, if you recall, going to our line, the near color is just set to 0.8. It's kind of multiplying everything by a light gray. So changing this to 1 gives us that, pure white. The color variation is now matching our ramp more directly. Yeah, and I think that the last thing that I had that's not here was I did give them noise some, like a little more animation. I had just created an LFO and used that to drive the harmonics, because I was playing with this and I kind of liked that springy quality when you add the harmonic gain. So what we can do is take our LFO, let's make the amplitude 0.5 and the offset 0.5. Cool, so it's going from 0 to 1 now. And just like plug that in to our harmonic gain. All right, it's a little bit fast, so let's bring that down a little bit to like 0.3. Yeah, and you can play with the speed, the shape. You don't have to vary this parameter. Play with all sorts of things, like the period actually gets pretty interesting, especially when we ramp this up. You can tone it down with a math if you want to say not go from 0 to 1, but maybe 0.8, so it doesn't quite get as extreme in those the harmonic gain. But yeah, this is pretty much what we've got. One other thing you might notice is sometimes the edges are a little bit like not the crispest, so we could change the anti-alias and bring that up to like 16 high. Pretty subtle, but if you do see any kind of weird aliasing, that can help by doing that in the render. This is always just a handy thing to know. Do note that it can increase the memory required and the processing for the GPU, so it's pretty lightweight in this case, but can get kind of intense. Yeah, and just play with the line material more. There's a lot more to be had in the snippets, as I said, and I hope this gave you some useful tricks for getting variable line width using the line material. So thanks for watching, and until next time.